This video shows the requirements, the calculation and interpretation, as well as reporting the results for the one-sample Wilcoxon rank test in R. Its aim is to compare the sample median and a hypothesized median or population median for differences. Let's quickly talk requirements. The dependent variable or test variable should be at least on the ordinal scale. Furthermore, the observations in your sample need to be independent from each other. My calculation example consists of 51 people being asked for their age, and I want to see whether the observed median differs from a hypothesized median of 30. As a first step after importing data, I want to see the median age for my sample using the median function. It is 36 and an indication that it might be different, statistically significant speaking, from the hypothesized median of 30. For this, I use the wilcox.test function and start off with the test variable. After that, I use mu equals 30 to test my sample median against the population median of 30. Note that the default testing will be two-sided, meaning you test only for a difference. In case you proposed in advance that your sample median is larger than the population median, you can add the argument alternative equals greater, meaning your sample median is greater than the population median. If you, however, hypothesized a smaller sample median, you use alternative equals less. Note, if you need confidence intervals for reporting, you can request them with conf.int equals true. And a final note, the calculation of the p-value will be exact by default. This will, however, fail if you have ties, meaning at least one value has a count of at least 2. Set the argument exact equals false if this is the case. I can run this one line and get the results. If the p-value is below the predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no difference between sample median and proposed population median. In my case, I defined alpha as 0.05 and can therefore reject the null hypothesis because my p-value for a two-sided test is 4.95 times 10 to the negative 10. The difference between my sample median and the population median is therefore statistically significant. Please note that the pseudo-median shown here differs from the calculated median in case you have a skewed distribution. No worries though, you can ignore the pseudo-median in almost all cases. Finally, if I tested one-sided for a larger sample median than population median, I could certainly see a significant result as well, because the two-sided p-value is halved. After a significant one-sample Wilcoxon test, the effect size should be calculated. The first step is installing a new package called rcompanion, using the install.packages and the library function. The second step is using the Wilcoxon one-sample R function within this package, which calculates the effect size R. The test variable and the hypothesized or population median have to be entered into this function. The syntax is almost the same as for the wilcox.test function. Simply put x equals in front of your test variable. After running this line, you will only get one number as output, the effect size R. In my case, it is 0.872 rounded to 3 decimals. The third step is to classify the magnitude of this effect. If similar studies in your research field exist, compare your effect size with the given one. If no comparable study exists, use the common thresholds within your research field. If those are also non-existent, you can refer to Cohen 92, a power primer. Page 157 shows 3 thresholds for the effect size R. If R exceeds 0.1, it is a small effect. If it exceeds 0.3, it is a medium effect. And if it exceeds 0.5, it can be classified as a large effect. When you're done, you have to write up the results. The test statistic, meaning the Z statistic, needs to be calculated manually, unfortunately. Field 2012 on page 665 shows how it's done. Simply use the qnorm function on the halved p-value. Since the p-value from the wilcox.test function is rounded, I suggest putting the Wilcoxon test results into a vector and refer to the p-value in that way, as you can see on your screen. Now it comes to reporting. First, one formulates whether the sample median is different from the hypothesized or population median. For this purpose, the calculated Z value is reported together with the p-value, and in the case of a significant difference, i.e. effect, also the calculated effect size R. Finally, the magnitude of this effect is classified with, for example, Cohen 92 or the respective research field specific thresholds.